We are going to find the rectangular coordinates of this point that is given in polar coordinates. Remember, in polar coordinates, the first coordinate is r, which is the distance from the origin, and the second coordinate is an angle, which is the angle from the polar axis. So this point, if we begin with the polar axis, which you can equate to the positive x-axis, and we move out 3 units on the polar axis, and then since the angle is positive, we will move counterclockwise a measure of 5 pi over 6 radians, and what would be the second quadrant in rectangular coordinates is where this point lies. And that is how you graph a point in polar coordinates. And what we are going to do is we are going to determine the rectangular coordinates of this point given its polar coordinates. To do that, we are going to use the conversion equations to find x and y. Recall that our point in polar coordinates gives us r and theta, and the equation for finding x is r times cosine theta, so we can substitute the values for r and theta and then evaluate cosine of 5 pi over 6, which is negative square root of 3 divided by 2, so that the x-coordinate of this point is negative 3 times the square root of 3 divided by 2. And the conversion equation for finding the y-coordinate is r times sine theta. So if we substitute the values for r and theta here, then we evaluate sine of 5 pi over 6, which gives us 1/2. So we have y equals 3/2. So therefore, the rectangular coordinates of our point in polar coordinates are negative 3 times the square root of 3 divided by 2, 3/2. If you remember, I noted that the point in polar coordinates would be located in the second quadrant in rectangular coordinates, and that agrees with what we have found here. We see that the x-coordinate is negative and the y-coordinate is positive, which places this point in the second quadrant. There you have one method for checking your answer.